Hi everyone. Apart from all the LLMs and frameworks that are getting released, there is a very significant release by Microsoft MatterGen, which is an AI model for material design and discovery. So this is looking to be a game changer of a model in the material science industry, and we will be talking a little about the model today. The Microsoft has open sourced this model, and you can get started with it as well. So before we jump on to, I feel that the audience might not be knowing what is material design and discovery. So it is a very important aspect which revolves around processing and creating new materials. This is a very unique idea, like talking about it. This field is quite crucial in advanced technology, improving products, solving global challenges like energy efficiency. In healthcare, you are getting different types of equipments. All this comes from material design and discovery. So this is a very similar model for, as we have LLMs for text generation, we have diffusion models for image generation. Now we have MatterGen for material design and discovery, which will help you to generate new material designs and new material discovery. This is a very unique problem that the team has very briefly shared in the blog, and I'm trying to cover the basics of it, like just to have an introduction. Material design and discovery involves a number of things like designing new material, creating material from specific property, like it has to be a tensile strength of X, conductivity of Y, flexibility of Z. Discovering new material, like you are wearing different types of clothes, cotton you are wearing silk. How are these material types getting identified? Discovering new material, optimizing existing material, improving the performance of known materials. Now, this process traditionally involves like how a new material gets discovered. Experiments, like you go for hit and trial, and eventually you will figure out that okay, this is a product that is working for us. Computational methods, I think simulation is something that is quite common, and data driven approach. But right now, this industry is quite manual. Like a lot of time is goes, and this is where MetaGen can be a game changer. Now coming to what is MatterGen, it is a generative AI model specifically designed for material science. It can generate new materials, create novel materials from specific properties as we discussed, optimize existing one, and predict material properties. Like for example, if you're expecting to create some products like XYZ, this is I'm talking about hard products, right? So it can decide, okay, it can discover what can be its potential conductivity, strength, etc. This is a little offbeat, not for everyone, but can be a game changer in the material science industry. Now, talking about how the model works, so there is a diagram that the team has shared. I will just switch to that first. So, if you look into this diagram, the first process is the manual process, how things are done. So, here you can see that this is a funnel. Take this funnel as a list of properties the team want. Now, they would be trying out multiple combination, and then finally, after hit and trial, they would be getting a final combination. Now, with MetterGen, what will happen? You are investing a shape and you're investing a color. Whatever your properties are, you're giving it to MatterGen, and MatterGen comes out with a new product. This is crazy. So, like for example, you wish to have scissors, but for say cutting your hairs by your own. Now, in that case, it you might be giving it a shape, you might be giving it a color, you might be giving it different aspects, like it should be small, it should not be metallic. I don't want to get it cut on my head. In that case, you will be feeding all these properties to MetterGen, and it would be coming out with the whole plan how the new product looks like, what would be its properties, and how to create. So here you can see that how does MetterGen works. The process begins with a wide array of initial structures represented by colorful shapes, evaluation and refinement, and optimized output. The final step delivers a set of highly refined structures. Now, powered by MetterGen, at the heart of this process is MetterGen, a cutting edge AI tool that will help you to generate the output. So it's very easy. The team has given a very brief around the model working and all. So we are just touching the base. As is a little offbeat, also I don't want to deep dive into it, but just to give you an idea that this is also getting developed. Talking about MetterGen architecture, as the team is saying, it is a diffusion model, but for material science. So basically, we are most of the image generation model follow diffusion architecture. So MetterGen also follows the same. It is, but for material science. How it works starts with a random structure and then refines position, elements, periodic lattice, etc. These are all chemistry and physics terms specifically designed to handle periodicity and 3D geometry in material structures. This is very important. Talking about key features of MetterGen, It is a property driven design. Users can specify desired properties that I wish to have high conductivity, low weight. Multi objective optimization. You can provide multiple properties together and it will be coming out with the final output. Accelerated discovery. As you can see, it is a very highly manual process. MatterGen can significantly reduce time and integration with experiments. Why is it important? I think by now you might have understood its importance, that it can really revolutionize material science. Now, the process of discovering new material is now on your hands. You just need to run a model and you would be getting multiple options to select from. It has application across industries, especially the hardware industry. Faster semiconductors, construction is there, healthcare is there. Everything can get revolutionized by MatterGen, and it is sustainable also. Like you won't be conducting out many experiments, you would be going all through simulation using MatterGen, and I think you would be getting results faster. And you can also contribute to global challenges like climate changes and resource scarcity using MatterGen. So a lot of things here is certain examples, like for case battery material that we use in our cars. Design new material for lithium ion batteries with high energy density and fast charging times. So in this case, it can give you a design for the new lithium ion batteries. Catalyst in chemistry reactions, lightweight alloys for aerospace and automotive industry, biomaterials for hospitals and medical implants. So concluding, I think we are not jumping much into MatterGen and take this as just an introduction, but this looks to be a great generative AI model. The GitHub repo is also open source by Microsoft. You can run that, you can try out MatterGen, and you can think in the direction of material science. What are different use cases you can solve using it? This is very important because for a very long time we have been hearing a lot about text generation and image generation and at times video generation. But this is a new model and a new space that generative AI is opening us for. Now here is the GitHub repo for MatterGen. As you can see by Microsoft, everything is open source, installation guide is present, and you can run the model straight away. Here you need to provide different types of condition. You are using the pre-trained model here now, and these are the different information present that you can pass out. Just go to the repo if you wish to run it. I don't think so it is a repo that would be required by daily professionals, but I think it is very industry driven and would be a game changer for the design industry, for the material design industry. Thank you so much.